Epistasis is an expression of alleles at a locus that dominates or modifies the expression of alleles at another locus. This leads to the interaction of two different genes when multiple genotypes can lead to the same phenotype. Now, what is a locus? In the picture, a pair of homologous chromosomes are shown. On each chromosome, there are two loci for a certain gene. There are 6 types of epistasis, but I will only be covering single dominant epistasis. To show single dominant epistasis, I will be using a werewolf gene and a coat color gene. The dominant allele on the first locus will represent a normal individual. I'm going to assign the letter big A. The recessive allele, little a, will represent a werewolf individual. On the second locus, the dominant allele will represent a brown coat color, big B, and a recessive allele will represent a white color, little b. In single dominant epistasis, if the dominant allele is on the first locus, it will mask or dominate the allele at the second locus. However, if the first locus is recessive, then the second locus is not masked. In other words, if the gene has a dominant allele on the first locus, it will mask all other alleles at the second. As seen in the pathway, the genotype with a big A inhibits the enzyme which would activate the werewolf gene, so big A individuals are normal. However, genotypes with little a produce enzyme 1, which activates little b, and produces a white werewolf intermediate. The genotype little a, big B produce both enzyme 1 and enzyme 2, which would allow them to become a brown werewolf. Using the pathway, there are 4 possible genotypes and only 3 phenotypes, as seen in the key: a normal individual, a brown werewolf, and a white werewolf. The normal individuals have the dominant big A, and the werewolf individuals have the 2 little recessive A's. However, the difference between coat color comes on the second locus with the dominant B allele for brown and the little b recessive alleles for white. Let's look at an example using a dihybrid cross with 2 normal individuals. In the 2 small Punnett squares shown on the right, you can see the cross between the 2 parent individuals themselves. Doing this helps see the alleles and the phenotypes of each parent. Then, taking the genotypes of each parent, I put them in the big Punnett square on the left. The big Punnett square shows a dihybrid cross. The Punnett square allows us to get all possible genotypes for the cross. As seen under the Punnett square, there are 4 different genotypes that are possible. However, since this is single dominant epistasis, there are only 3 phenotypes, so the ratio comes out to be 12 to 3 to 1, stating 12 normal, 3 brown werewolves, and 1 white werewolf. Another cross we will look at is between a normal individual and a brown werewolf. As seen in the Punnett square, there are 4 different genotypes. However, there are only 2 phenotypes: normal individual and brown werewolves. It gives a ratio of 1 to 1.